Welcome to Unit 3 Solutions, Lecture B, using Reference Table F. Say hello to Bella. Reference Table F will tell you whether something is soluble or insoluble in water. Notice that it says for aqueous solutions. So right here it says it's for aqueous solutions, so that means for all of these our solvent is water. If they want to ask you about the solubility in any other solvent, they're going to have to give you a different set of information. All right. Some of the things that I don't like about this graph is some of the things that I don't like about this reference table is that it's really two different reference tables. If you take a look, there's a line right here. There's a big gap. You have two separate reference tables. On the left, we have soluble compounds. And on the right, we have things that are typically insoluble compounds. And then, of course, my least favorite part, we have exceptions to these rules. So the way this works is that on our soluble side, over here, the left side, if your compound contains a group 1 ion, so this refers to group 1 on the periodic table, lithium, sodium, potassium, rubidium, as you're going down group 1, those compounds are soluble in water. There are no exceptions. They're always soluble. That's great. If you see ammonium for your positive ion, always soluble in water, no exceptions. Nitrates for your negative, acetate for your negative, hydrogen carbonate for your negative, chlorate, perchlorate, all of those for your negative, always soluble, no exceptions. Then, of course, we have this exception side. What exception means is, on this side of the table, things that are insoluble. So halides are going to be things in group 17. We call group 17 on the periodic table the halogens. So the compounds that they make when they're negative ions, halogens, become halides. Remember IDE for negative ions. So if it has chlorine, bromine, iodine for his negative ion, those are usually soluble. But if you have silver chloride, silver bromide, silver iodide, lead 2 chloride, lead 2 bromide, lead 2 iodine, or mercury 1 chloride, mercury 1 bromide, and mercury 1 iodide. Notice that this is the mercury 1 polyatomic ion. Then those compounds would be insoluble. Sulfates. Most of the sulfates are soluble except silver sulfate, calcium sulfate, strontium sulfate, barium sulfate, and lead 2 sulfate. Those are all insoluble. On the right side of the chart, we have things that are typically insoluble. So if these are the things that are typically insoluble, then their exceptions must be soluble. So most of the carbonates are insoluble unless they're combined with a group 1 or ammonia. Most of the chromates are insoluble unless they meet these conditions, and so on and so forth. So you have to be really careful when you're looking at these things. Things that I look for first are these guys over here. I look to see if any of these items are in my compound because there are no exceptions to that, and that helps out a lot. Okay, we're going to look at some sample problems using reference table F. All right, let's look at the one in your notes first right here. According to table F, which of the following saturated solutions would be least concentrated? One of the things that happens with this question, and I know why it throws students off, because it really is a lot easier than you think it is. Because they've thrown in this saturated solution part, you want to go to reference table G. You want to see numbers, you want to know amounts. But they told you to use reference table F. So instead of worrying about why you don't see the numbers, let's just do what reference table F tells us. Sodium sulfate. Sodium is in group 1. There are no exceptions. He's always soluble. Potassium sulfate. Potassium is in group 1. He is always soluble, so no exceptions. Copper 2 sulfate. So I don't have a group for copper, so I have to go to the sulfate group. Here he is down here. Copper 2 sulfate, not in any of my exceptions, so he must be soluble. And then barium sulfate. Here's sulfate again. I don't have a category for barium. Here's barium sulfate. That's an exception. He is insoluble. Sesame Street tells me that this guy must be the right answer then, because 3 of these things belong together and 1 of these things just doesn't. Chemistry-wise, what this means is if it's the least concentrated, that means the least amount dissolves. And 0 dissolving would be the least amount. So the insoluble one would be your answer. A little tricky, but again, just don't panic and do what the question is telling you to do. If they're telling you to use reference table F, see what reference table F does and see if that gives you any hints. Okay, next one says, when lead 2 iodide solid is added to sodium carbonate aqueous, a white precipitate is formed. According to reference table F, the white precipitate most likely is. Okay, we haven't talked about how we form new compounds when we put these things together. But law of conservation tells you your answer has to be made with either lead, iodine, sodium, carbon, and oxygen. Those are the only things you can recombine. So the first thing I would do when I look at this question is I see a potassium. There is no potassium up here at all. Crossing that answer off because that one doesn't obey the law. Lead, carbon, and oxygen were okay. Sodium and iodine were okay. Sodium, carbon, and oxygen were okay. The next thing I would do is say, well, this is going to be some kind of reaction. This guy's a solid, and he's not one of my choices. This guy was aqueous. That means he dissolved. He can't be the precipitate. I must have made new compounds. So I'm going to cross him off down here because I already know he's aqueous. I know he's soluble. That leaves me with lead carbonate and sodium iodide. Now it tells me to use reference table F. I go to reference table F. Sodium's in group 1, so they're always soluble. And lead carbonate, there is no group for lead, so I have to go to the carbonates. And the carbonates are insoluble except with group 1 or ammonium. Lead's not in group 1, so this guy must be insoluble. Your insoluble is your precipitate. The stuff that doesn't dissolve is your precipitate, so there's your answer. Take your time and work through the questions step by step and use what you know at each step along the way. Next example. This one's from the short answer section. Calcium hydroxide, so calcium hydroxide is CaOH2, is commonly known as agricultural lime and is used to adjust the soil pH. Before the lime was added to a field, the soil pH was 5. After the lime was added, the soil underwent a 100-fold decrease in hydronium ion concentration. According to reference table F, calcium hydroxide is soluble in water. Identify another hydroxide compound that contains a group 2 element and is also soluble in water. Okay, now first, notice that the paragraph that goes with this question talks a whole lot about pH. And the only part that you need out of this paragraph to answer this particular question is the formula for calcium hydroxide. This is going to be part of a multi-step question on your final. On the final, they'll mix acid-base questions in with solubility questions. If they relate at all, they'll put more than one concept in the same question. So they want a hydroxide. So here's the hydroxide. That is soluble, that contains a group 2 element that besides calcium. So here's the calcium. That's the example they gave us. So I would just pull up the periodic table and find a group 2 element that's in your exceptions, that's in the soluble side. Both barium and strontium are in group 2. So your answers could be either barium hydroxide or strontium hydroxide. And you could use either the names or the symbols for those things. It's up to you. It's really easy to just pull the name and call this barium hydroxide, and then you don't have to worry about writing the formula wrong. And this one, of course, would be strontium hydroxide. If you don't know how to spell them, you have reference table S. All right, we'll practice more in class.